So the sun emits radiation, and it emits radiation at a wide spectrum. Gamma rays all the way at one end through UV, visible light, and infrared light. The majority of the sun light that we see obviously is visible. The majority of the light that reaches the Earth gets absorbed in other components. It gets absorbed high up in the ozone layers. It gets absorbed in the transit from the sun. And so only about a chunk of the light reaches us. But that chunk of light that's been reaching us is fairly significant. And there are relevant particular wavelengths of light that are important for the health of our systems. Now, I want you to keep in context that our mitochondria are primitive prokaryotes, are cells engulfed. And that is why those mitochondria, that's how we derive our ATP. And it's those mitochondria which have their own dual bilayer and have their own set of DNA and really are independent of us, even though they only produce about 15% of their own protein structure and rely on our nuclear DNA to produce the other 85%. They have unique characteristics, and those unique characteristics are contained throughout almost all plant and animal prokaryotic cells and eukaryotic cells. And so it's really important to understand that there's a connection that goes all the way back. So essentially the mitochondria are primitive prokaryotes that the eukaryotes engulfed, and they have their independent system that's contained. And that's why, if you think about it a little bit, that transmission of mitochondria is maternally derived. That's why you don't get mitochondria essentially from that ovum. And it's that transmission in that way rather than from the father's lineage. Thank you.